Hi, this video is made with you in mind. You have that important job of keeping machinery running. We at Vooner Vacuum Pumps think that a picture on videotape is worth more than 1,000 words. We hope the following guidelines will serve as an aid to your written installation, operation, maintenance manual by Vooner with numbered sections. Now let's take a look at how the video is organized. On the videotape box, you'll find a table of contents. Every section we'll cover in the video is numbered like this. At the beginning of each section in the video, these same numbers will appear on the top of your screen, just like this. So you can search for whatever section you want to review. So, let's get started.
For optimal performance of your Vooner vacuum pump, special care should be taken to ensure the piping is correctly installed. Let's take a look at the recommended installation technique, then follow up with descriptions of some common errors and how to correct them.
First, let's take a look at the recommended installation for inlet or suction piping. All suction piping should be horizontal or downhill to the vacuum pump. Short drops with 90-degree elbows should be used to prevent process liquids from entering the pump at high velocities. Also, consider using a dirt pocket to collect solids, keeping them out of the pump. If uphill piping is necessary, a U, like this, should be piped in the process to collect water and prevent the pump from having to pull process liquids uphill. A drain line from the U to the vacuum pump must be used to allow the liquid to drain. We don't recommend using any uphill inlet suction piping if there is liquid being pulled from the process. The vacuum pump is designed to move gases and will not pull large amounts of liquid uphill without great line losses and reduction of needed airflow. Additionally, vertical drops of 8 feet or greater into the vacuum pump are not recommended. Any process liquid will achieve high velocities, and this could cause damage to the vacuum pump. Here is the recommended installation for the temporary inlet screens and strainers you need to use during the first week of pump operation. For the first 120 hours of pump operation, Vooner suggests installing a cone-shaped basket screen in your suction piping. It will be attached to a spool piece like this, here. This will keep dirt and debris, such as weld slag, from getting inside the pump. After 120 hours of operation, the strainer should be removed by using the spool piece. A flat screen can be used as long as a cleanout port is installed here, before the screen, so dirt and debris can be scooped out before the screen is removed. Avoid using a flat inlet screen with no cleanout port located ahead of it. If dirt and debris aren't removed before sliding out the screen, it may fall into the pump and could cause damage. For discharge piping from the vacuum pump to the discharge separator silencer, we recommend that piping run downhill or at least horizontal from the discharge manifold, shown here. This will allow the vacuum pump discharging seal water to drain freely without adding pressure to the rotor, shaft, and bearings. Also, downhill or horizontal piping allows your pump to self-drain while it's not in use. This will prevent the vacuum pump from starting up while flooded, which can cause extra stress on the pump. We don't recommend using uphill discharge piping because it places additional back pressure from the discharging seal water on the pump rotor, shaft, and bearings. This eventually leads to pump failure. For a typical Vooner Vane Guard application, horizontal or slight downhill piping from the process to an inlet separator should be used. The inlet separator will allow process liquid and other carryover to be removed and prevent it from entering the vacuum pump. The piping should be sized to keep the air and liquid velocity below 3,000 feet per minute. Also, avoid short radius turns to prevent friction losses. A straight vertical barometric drop leg line from the inlet separator to a seal pit, shown here, is designed to remove the water from the separator. The distance from the water level in the separator to the water level in the seal pit should be greater than 1.13 feet times the vacuum level in inches of mercury vacuum. Failure to do this will cause the water to be carried from the separator into the vacuum pump. One possible substitute for this barometric drop leg is a low net positive suction head, or MPSH, centrifugal or air-operated diaphragm pump like this. This should be sized to keep the liquid level below the separator inlet and require a low enough net positive suction head in order to prevent cavitation. From the inlet separator to the vacuum pump, air and vapor piping should be sized to keep velocity below 5,500 feet per minute. And again, avoid vertical drops greater than 8 feet. Use horizontal or downhill piping from the vacuum pump to the discharge separator silencer. This piping should be at least the same size or larger than the pump discharge.
Here is the table of recommended inlet pipe sizing guidelines for your installation. Preparing the pump for startup. Before installing your Vooner pump, we recommend flushing the pump with water and allowing it to drain through the bottom drain plugs. This will wash away any debris that may have fallen into the pump during transportation or storage. After flushing the pump and installing the drain plugs, rotate the shaft by hand. For larger pumps, you may need to use a hand shaft wrench. If the rotor shaft does not turn freely, contact your Vooner sales representative or the Vooner headquarters for assistance. If the shaft does turn freely, the pump is ready for installation and operation.
All Vooner pumps ship from the Charlotte, North Carolina headquarters with the bearings fully lubricated and ready for startup. No additional lubrication is necessary to operate your pump. Vooner's standard bearing package features bearings with standard grease and radial lip seals. For further bearing protection, Vooner also offers bearing isolators as a substitute for the lip seals. The isolators are designed to further prevent the bearings from becoming contaminated with any foreign substance. To better protect your bearings, Vooner strongly recommends its 3-year maintenance-free bearing package. This package comes complete with a synthetic lubricant, automatic bearing lubricators for both bearings, and bearing isolators, and is designed to protect your bearings without lubrication maintenance for up to 3 years.
Bearing inspection and relubrication after 6 months of operation.
Vooner pump bearings and lubrication should be inspected for contamination after every 6 months of operation. Lubrication periods before this time are not necessary, and because over-lubrication is a primary cause of bearing failures, Vooner strongly recommends no additional lubrication be added to the bearings during each 6-month interval. After completely shutting down the pump and accessing the drive-in bearing by removing any drive items from the shaft, use a rag with fresh, clean solvent to clean the outside of the bearing caps and the bearing housing. Get rid of as much dirt and debris as you can. Remove the outer bearing caps from both ends of the pump and be careful to keep the free end shims intact. Then, slide the inner bearing caps in toward the stuffing box and packing gland area. Look carefully at the lubricant in these caps and bearings. If the grease looks very clean and free of metal particles, reinstall the bearing caps and you are ready to restart your pump. If the grease is contaminated, but the lip seals or bearing isolators are not damaged, the grease should be replaced, but the bearing does not have to be removed from the pump. This is done by first removing the grease from the bearing caps by wiping clean with a rag and solvent. Be sure to wipe away as much used grease as you can from the bearing caps, housing, and bearings. Next, remove the plug or plugs from the bearing housing and, for now, replace these plugs with grease fittings like this. You can use a hand-operated grease gun to pump new grease into the bearing through the grease fitting while slowly turning the shaft by hand. Watch as the old, used grease is pushed out of the bearing and replaced with fresh lubricant. Keep doing this until all the old grease is out of the bearing. Next, wipe away all the old grease. With a trowel, fill the bearing cap reservoirs 2/3 full with grease. Then replace the caps along with new gaskets, taking care to install the shims on the outer free end cap exactly the way you took them off. Next, remove the grease fittings from the bearing housings and reinstall the plugs. Your pump bearings are now fully packed. If there is damage to the lip seal or the bearing isolator, the bearing must be removed and inspected for damage. Finally, any metal particles found in the grease directly around the bearing could indicate a worn or failing bearing. And if a bearing is damaged, it must be replaced.
Bearing removal for Vanguard models.
As many of you know, changing a bearing on an old vacuum pump is very time-consuming and at a high cost. You have to remove the pump from the piping, and you have to disassemble the pump. But with the new Vooner Vanguard bearing carrier, you can remove the bearing without removing the pump from the pipe, and you can do it very quickly. Take a look.
Begin removing the bearing by taking off the outer bearing cap, shim gaskets, and shims as shown earlier. Carefully measure and record the total thickness of the shims and gaskets. Next, take off the bearing lock washer and lock nut. If you're working with drive-in bearing carriers on models VG3 through VG20, there will be no lock washer or lock nut. Install all the long bolts with extra flat washers through the bearing carrier, threading into the tapped holes of the inner bearing cap. Tighten these bolts until the inner cap is flush and tight against the inboard face of the bearing carrier, like this. Because the bearing carriers and bearings of VG7 through VG40 are heavy, a sling or chain will be needed to provide extra support before moving on with disassembly. This will help prevent both personal injury and damage to pump parts. Now, take off the bolts that secure the bearing carrier to the head and loosely install the bolts in the threaded holes in the bearing carrier seen here. Jack the bearing carrier, complete with the bearing and inner bearing cap, away from the head by equally tightening the bearing carrier bolts inserted in the threaded holes of the bearing carrier. If the inner bearing cap is equipped with lip seals, they should be replaced. However, don't remove bearing isolators from the cap unless they are visibly damaged. Reinstalling the Vanguard bearings and bearing carriers is just as easy as removing them. For instructions of this procedure, again, please refer to your installation, operation, and maintenance manual.
Setting rotor cone travel. One of the most important things that will affect the performance of your vacuum pump is the clearance or distance between the tapered surfaces of the cones and the rotor. These clearances are checked and set by moving the rotor shaft and bearing assembly until the rotor and cones are touching. This is called the end travel, and we'll explain it in more detail in just a little while. The measure of distance the rotor travels from being locked tight against the drive-in cone to being locked tight against the free end cone is called the hard-to-hard travel. The measure of distance the rotor travels from first touching the drive-in cone to first touching the free end cone is called the touch-to-touch travel. Let's talk about each one separately.
The hard-to-hard travel measurement is a maximum measurement, so anything less than that maximum will improve the efficiency of your pump. Here are the maximum hard-to-hard distances we recommend. Each model has a tolerance of plus 10%. Here's how to check the hard-to-hard travel of your vacuum pump. First, always use the free end to measure the travel with a dial indicator, and be sure the outer free end bearing cap is installed without the shim gaskets. Tighten the through bolts connecting the free end inner and outer bearing caps. Once you've done this, tighten the 3 jack screws that thread into the outer bearing cap and push flush on, not threaded into, the bearing housing until the rotor is locked hard onto the free end cone. Please use caution not to force past this point. Next, remove the jack screws and place a dial indicator on the free end bearing cap and zero the gauge. Then, tighten the 3 take-up screws that thread into the bearing housing through the clear holes in the bearing cap until the rotor is locked hard onto the drive end cone. Remove the take-up screws to relieve tension on the bearing. Then, read and record the dial indicator measurement. Congratulations! You've just successfully measured your hard-to-hard travel. Reinstall and slowly tighten the jack screws until the dial indicator reads half of the hard-to-hard travel. The rotor is now centered hard-to-hard between the 2 cones. The touch-to-touch travel measurement is the minimum measurement needed for safety to prevent contact between the rotor and cone tapered surfaces. So, in other words, anything greater than the minimum measurement offers you more safety. Here is a list of the minimum touch-to-touch distances for each pump model, with a tolerance of -10%. Here's how to check the touch-to-touch travel. First, with the rotor centered between the cones, zero the dial indicator. Then tighten the jack screws until the dial indicator reads 5/1000ths of an inch toward the free end cone. Rotate the shaft slowly by hand, listening carefully for the first contact of the rotor and the free end cone. If there is no contact, continue to tighten the jack screws in increments of 5/1000ths of an inch toward the free end cone and rotate the shaft slowly until light rotor cone contact is heard. Then record the dial indicator reading. Next, remove the jack screws and install the take-up screws. Slowly tighten the take-up screws until the dial indicator again reads 0. Then tighten the take-up screws until the dial indicator reads 5/1000ths of an inch toward the drive end cone. Again, rotate the shaft slowly by hand, now listening carefully for the first contact between the rotor and the drive end cone. If there is no contact, continue to tighten the take-up screws in increments of 5/1000ths of an inch toward the drive end cone and rotate the shaft slowly until the first rotor cone contact is heard. Then record the dial indicator reading. Finally, add these two dial indicator readings. This sum is your touch-to-touch travel.
If your hard-to-hard or touch-to-touch measurements do not match the Vooner values that are recommended, refer to your Installation Operation Maintenance Manual for instructions as to how to correct your vacuum pump end travel. We at Vooner hope that you find this video both helpful and informative. It's dedicated to you who keep critical equipment running. As always, both your Vooner Installation Operation and Maintenance Manual and your Vooner local sales rep are available for further questions on points that have not been covered in this video. You can also call Vooner direct, toll-free in the United States and Canada at 1-800-345-7879. Thanks for your time. Remember Vooner, when protecting vacuum counts.